go for the next part. Just I think once you learn this method, it will be very easy for you, nothing big. So now let there be a rigid body. I'm going to apply a force above the center of mass. Let me call this as a threshold point E. Also like some point A I'll call it. So when I'm applying this force above the center of mass here, this is the center of mass and this is a point P which we are taking help that one, and the surface is rough. And now what should be the expression for acceleration of center of mass and this one. So where the force is applied above the center of mass of system. Okay, now we have to work out the conditions here. So I'll begin like this. What action friction I should take? The very first question student ask himself like, no, I apply force F. So when I apply force F, then the point P what happen will try to, when I apply force F, the center of mass will have translative motion. Then all points should also have translative motion. So the point P in what direction will try to move? Will try to shift towards right. Then friction should oppose relative motion. So friction will act backward. At the same time, you see that capital F into small r will set up a torque, no, about center of mass. This is smaller, this F, clockwise. And because of this particular point, what happen? Will have tangential acceleration. Then the friction will act forward. So I think this is some sort of like a trouble, no? If you look at the translative motion, friction should act backward. If you look at the rotative motion about center of mass, friction should act forward. So then it's like a paradox, no? Like how to predict here. So just you assume any one direction, solve it. If you get negative, change the direction. If you get positive, what you assumed is right. So I'll proceed like this. I'm going to assume a friction like this here. Then acceleration of center of mass. Then it set up a torque. This one. So what is the acceleration of point P along x-axis? Must be 0 for pure rolling. Let's write the torque equations. F plus F equal to mac. There's a translatory motion of center of mass. Then the torque equation F into R. F into R, this will be what? Like clockwise torque. Torque by friction. This is friction like this, and this is capital R. So how is the torque? Torque will be anti-clockwise. I think by this time, I told you like, say what all you learn earlier torque, that are going to help you here now. Now look at this one. Small r into capital F. Torque is clockwise. What about here? Capital R and this is F. So this will be anti-clockwise. So therefore, minus F into capital R is equal to IC alpha C. What are the unknown things? AC and small f, friction force. So let's solve for them. So I'll substitute R alpha C equal to AC. Substituting in this equation, F into R. IC alpha C will be AC by R. Solving for AC. So let me substitute the value of F here. So this will be R minus capital R is equal to IC AC by R minus sorry MAC minus small f I'm substituting, no? So MAC minus F. So this should become small r plus capital R. This should be equal to IC AC by R plus MR AC minus sign. Yeah. So F into small r plus capital R. This will be IC, I'll take common, AC minus MR square.
Sir, plus, sir.
This will be plus, sir. Yeah. Check it once. So this will be F into small r plus capital R by. I brought this equation. Similarly, I want expression for friction. Anybody solve and just give it. Substitute the value of AC here. We'll keep it. This is a formula which, if you no need to remember, just have an idea. Acceleration of center of mass. Okay, after this, straight away, the value of AC, let me substitute in either this equation or this equation. So from this, I'll keep everything in order. Okay, let's proceed. No, substituting this value of AC in the first equation, F plus F equal to M into F into small r plus capital R. We have to solve this. We have to solve for small f, friction force. Anybody value? IC minus M capital R small r. Check it once. Please somebody solve it first. Without solving, how you say correct? Huh? You have to solve, no? Infinity value, small f. This will not be the answer. I'm very sure this is not answer at least. Don't say this is correct. Huh?
Sir, capital F into MR minus IC by IC plus M capital R square.
I'll write in order. Tell me first only numerator you tell me.
F into capital F into
Yeah.
M into small r
Yeah.
minus IC whole divided by.
Here one capital R will be there, no?
Yes, sir, there's a capital R there.
Yes, sir.
Will be
Yes,
there.
yes, sir, there will be capital R.
Divided by?
IC plus M capital R square.
Yeah, fine. Okay, this is something I think at least you have to remember this. This is no problem. At least you remember, or in numericals, we can manage this one. So there's a one very best equation I'm having. I'm going to analyze this, I'm going to take help of this equation. So whether friction will act forward or backward will determine the value of smaller. The value of smaller. So there's a generalized expression what we got it. And it will have a pure rolling. The body will have the applied force is such that it is less than F max and the friction is sufficient for pure rolling. There's the thing. Let me start with a ring. What all we have this formula. I'm going to apply directly for ring. In exams, you need not to remember formula. You have to directly write equation. I think we can see this formula. So this is the ring. Now for a ring, what is IC? mr square. So I took a ring. I'll apply force for the ring here. How the friction should act. Let me keep this. I'm going to take help of this particular formula only. Regarding acceleration, all only direction of friction I'm interested. Okay, I'm applying a force F here like this. Now tell me in what direction the friction should act here. I think we have a very good formula here, no? What is smaller? It is at a, what is smaller? Where the force is acting at a distance above the center of mass, that one. It is measured from the center of mass. If you measure distance above the center of mass, it should be taken positive. Smaller. If you measure the distance below the center of mass, you should take negative. So therefore, what is the conclusion? So one more thing I'll introduce. What is that? This is R equal to 0. Upward positive, downward will be negative. Fine. The convention is what I'm taking here now. Because if I measure, if I took this is positive, this CA is what I took positive. Then anything if I measure the distance below the center of mass should be taken negative. Okay, let's, what is smaller here? The first case smaller is 0. Then put smaller 0. Then what do we get? F will get negative, no? F will become negative. F negative means what? When the friction will act backward. Able to make it out? And how center of mass? Center of mass will accelerate like this.